Alexander again. Today we'll be doing some really interesting problem associated with the capacitor, and what's more interesting is that we'll have another relative permittivity epsilon r involved in. So let's start. Problem 157. An insulating sheet of relative permittivity epsilon r is slowly slid between the plates of a parallel plate capacitor, completely filling the space between the plates. So what force acts on the sheet if the charge or the voltage of the capacitor is kept constant during the process? So the first thing we do is we'll draw a little graph showing that when x is at here, let's assume the distance or the length of the parallel plate be L, the width being D. So the surface, the cross-sectional area will be LD, and here we have L minus X. In here we have the permittivity of epsilon R, and because it is completely filling in, so there's no this thing, but well, we can just ignore that. Here we have epsilon 0. So now we calculate the ultimate capacity. It is C equals to actually it's the sum of these two components, because it is connected in series, right? So remember the formula of the truly or the base capacitor. It's epsilon 0 epsilon R, because this is a relative permittivity, D over A, right? So now we have epsilon 0 epsilon R, A over D. We just use this, the cross-sectional area, and times we can use X and L minus X, but in order to make it easier, we'll use the partial of X. So here we have length X. Okay, so we have X over L plus epsilon 0 A over D, L minus X over L. Here it gives the result of this. And now, so in the first circumstance, we have the charge is constant, so the energy will be constant. So W will be Q squared over 2C, and this Q is not constant, but well, I mean Q over Q is constant, C we have calculated that, so we are going to calculate energy in this way instead of 1 over 2 times C times V squared. Have something like this. Now, so how to calculate the force? The relative force is the only thing that changes the energy of the capacitor. So F would be the derivative of W. To calculate that, we will get this. To epsilon 0 A. So now we have calculated that. We should also know about the energy, but yes, we have calculated that, and this is a force. So in the second circumstance, where voltage stays constant, Now we're going to calculate W in this way. And the result shows that it equals to where V is the initial voltage and F we do the same thing. Something like this. And to be noticed, now we have used Q equals to CV, this to calculate all the things involved. Now we have completely solved this problem, and thanks for listening. I'll be glad to see you next time.